Welcome to the Nutrient Cycling Soil Health and Food Safety Conference. I think we'll get started. I'm Rhonda Miller. I'm the moderator for this session. This is our afternoon session with the case studies. Our first case study is one from Utah, looking at anaerobic digesters in Utah. Smithfield Foods recently installed a bunch of anaerobic digesters at their swine production facility in Milford, Utah. They're actually converting the methane into renewable natural gas instead of electricity. And so this will have a presentation. We'll have a video first, and then Jim Webb with Smithfield Foods will do a presentation on that.
At Smithfield Foods, we're dedicated to producing good food responsibly. As a global food company, we're committed to doing business in a sustainable way throughout our entire supply chain. That's one of the reasons why we were the first major protein company to set an ambitious goal to reduce our greenhouse gas emissions across our entire supply chain 25% by 2025. To reach that goal, we created a new platform called Smithfield Renewables.
Smithfield Renewables is really the platform that we use to ensure that we make our carbon reduction goal. As part of that, you'll have biogas projects, you'll have fertilizer optimization, grain supply chain projects. You'll have a lot of different things that come together.
We're partnering with local contract farmers and leaders in the bioenergy field for a groundbreaking project underway in North Carolina. Together, we're converting manure from the hog farms into renewable natural gas.
The way we do that is we capture the manure in the buildings, in the underfloor of the buildings, and then that manure is flushed or transferred to an anaerobic digester or a covered lagoon where anaerobic digestion takes place and solids are broken down. Once those solids are broken down, it releases methane gas. That is captured in the digester or covered lagoon, and then that gas is then moved from there and transported to a central processing facility to be converted into renewable natural gas that can be used by our community.
This renewable source is expected to produce enough energy annually to power about 1,000 homes for an entire year.
This is the first time that we in the state of North Carolina have been able to put natural gas from any source into the pipeline and serve the customers in North Carolina.
We really like this model because it allows farmers to be involved, even smaller farmers to be involved in renewable natural gas production. And we feel like this is the most economical way to provide renewable natural gas to customers.
John Kilpatrick is a contract farmer for Smithfield Foods. He's been operating his North Carolina farm for 40 years. Participating in the project makes both environmental and economic sense for farmers like John.
The benefits would be the economics, selling the methane to gas, which would normally be a waste product, and why not capture it, use it, make a benefit from it. It's just a matter of putting the pieces of the puzzle together.
And at Smithfield Foods, we're putting those pieces together to form a seamless, sustainable supply chain from farm to table. Our Manure to Energy program is a part of that bigger picture.
Smithfield has long been a leader in the area of sustainability and innovation in our industry. These type of projects just further allow us to explore opportunities beyond what we've already done.
Learn more about Smithfield Renewables and about our other sustainable practices at smithfieldfoods.com/renewables.
Hello, my name is Jim Webb, and I work with Smithfield Foods, and I am the Director of Environmental Health and Safety and Public Affairs. And I'm excited to come and talk to you today about some exciting projects that we have going on here in Milford, Utah, as well as across the company. We all know what natural gas is, but what is renewable natural gas? Well, renewable natural gas is energy that's made up by capturing methane from hog farms and dairy farms, landfills, and other sources. It's the cleanest energy in the U.S. because it removes more greenhouse gases from the atmosphere than it releases. It's also better than zero carbon. It's actually carbon beneficial. So, these projects produce greenhouse gas reduction, clean energy for customers. There is a revenue stream for the family farmers, and it also improves the waste management. In order to create RNG, we first capture the methane from the farm by collecting it in large anaerobic digesters. Then that gas, that biogas, is taken to an RNG refinery where all of the impurities are scrubbed out of the biogas to create a 99% pure methane stream. And then that methane is then, or that RNG is then delivered to homes and businesses by an existing utility gas pipeline. In 2018, Dominion Energy and Smithfield Foods joined forces to create Align RNG, and they committed as part of that joint venture to invest over $500 million over 10 years to capture methane from Smithfield's hog farms, which is enough clean energy to power more than 70,000 homes. The 4 initial projects are in North Carolina, Utah, and Virginia, with more projects to come. At the first of this presentation, we watched a short video on one of the projects going into North Carolina. We chose to show that video not because it was of Utah, but because the principles that are contained in that video are very similar to what's going on here in Utah. Let's talk just a minute about reducing greenhouse gas emissions. RNG is carbon beneficial because it removes 25 times more emissions from the farm than are released when customers use the gas. Over the next 10 years, Align RNG will reduce those greenhouse gas emissions from the Smithfield farms by about the same amount as taking 500,000 cars off the road or planting more than 40 million new trees each year. RNG produces clean energy for consumers. RNG provides reliable energy 24/7, unlike a lot of the other renewable energies like solar and wind, which only produce during the light or windy times. RNG will provide energy around the clock. Manure management is typically a significant cost for family farmers, but RNG projects allow farmers to turn this cost into a revenue stream. Family farmers can invest in building the infrastructure on their farms and then share in the long-term revenues. So what does a typical project look like? A typical project consists of a cluster of about 15 to 20 hog farms. The hog manure from each farm is stored in anaerobic digesters, which break down the manure over a 12 to 18 month period, which produces methane gas. The methane gas is then captured from the digesters and sent to a centralized conditioning facility where it is cleaned into about a 99% pure methane, and then the methane is put into an existing distribution system for delivery to local homes and businesses. As part of the Align joint venture, there are 4 projects that are going on currently. There's 2 in North Carolina in Sampson and Duplin counties, and then there's 1 in Waverly, Virginia, and then there's also the one here in Utah, in Milford, Utah, which we'll talk a little bit more about, and I'd like to focus on. But the Milford one began construction in 2018 and is currently operational. These 4 projects combined will provide enough energy for 14,000 homes annually, and then is equivalent to an emissions reduction of planting 7.7 million trees. I'd like to talk about the project that we have in Milford, Utah. Of the 4 projects that we currently have going on, the Milford project is the only project that we have started from a clean slate. These farms were built specifically with digesters in mind, and they were brand new. The other 3 projects were all retrofits on existing farms and existing lagoons to create anaerobic digesters. So Milford is the first one. In Milford, we have installed 26 different farms. Each one of those farms has a permitted capacity of 9,200 hogs. feeding 26 individual digesters. And so those digesters then create the biogas, which then gets transported to a centralized conditioning gas scrubbing center, which you can see here on the lower picture with the 3 green boxes that are next to the big white building. That is the place where all of the gas gets scrubbed out, and then it gets loaded onto a collection pipeline, which then leads to a high pressure transmission pipeline. Those digesters have now been in operation for about 1.5 years. We have had some issues with those digesters, mainly that we put in a lot of fresh water. In order to install the cover, you have to install it at a certain level, and so in order to get to that certain level, we had to put in a lot of fresh water. And because we had to put in so much fresh water, it took a little while for those digesters to really start taking off. We had to seed those digesters with some dairy manure to create some methanogens, so that it would digest the manure a little more efficiently and produce the gas. But that has now been done, and we are seeing good gas production. The weather now this time of the year is starting to cool down, and so we are seeing some gas production wane a little bit, but overall it's been a really good project. Thank you for your time and attention, and I have appreciated the opportunity that I had here today to share a little bit more about our exciting project in Milford, Utah with the Align Renewable Natural Gas. Thank you.
Thank you. So that's the presentation. We have an opportunity now for live questions and answers. Jim Webb is online with us. And so if you have questions, if you'd please type them into the chat box, and we will go through answering them. So we have one from JR. Does anaerobically digested manure have the same fertilizer value as normal manure?
Yeah, so the anaerobic digestion process really only impacts the carbon portion of the manure. So you still are left with the nitrogen portion of the manure. Maybe it would definitely have less carbon in it, but as far as from a fertilizer value, from a nitrogen or a phosphorus standpoint, the manure is going to be pretty much the same.
Okay. And then another question, you talk about the smaller scale of animal units that you need to go ahead with one of these projects. How does this, what does that change in numbers? Can you explain that?
Yeah, I maybe didn't understand that question.
Okay. Well, it mentioned, I think in the video, that some of the smaller farmers could maybe join in. Is there a scale difference between using this where you have renewable natural gas versus electricity for the anaerobic digestion?
Yeah, so in our model, you've got to have enough animals. You've got to have enough ability to produce a certain amount of decatherms to make the payback onto the to pay for the gas scrubbing unit, as well as to pay for the interconnects on these gas lines. Usually these interconnects are in the millions of dollars. I just looked at one today, and we're looking at $4 million for an interconnect into a natural gas pipeline. And so in order to do that, you've got to have a certain number of animals producing gas to make the payback for the infrastructure. And so that's why in the video it talked about farmers signing up, and you need to have so many farmers sign up all together in a certain area so that you can afford the infrastructure to get the gas to the market.
Okay, so then how does this compare to using anaerobic digestion to produce electricity? Or why did Smithfield choose renewable natural gas?
Yeah, so Smithfield has experimented with taking natural gas and running it through gen sets and creating power. The problem with that becomes, well, it's all about economics. So renewable natural gas is, it's one step less than producing electricity. And with the low carbon fuel standard in California, and the returns that you're seeing there, it's much more financially lucrative to go to California with your gas than it is to run it into to generators. And I would say that is, running gen sets and creating electricity is really kind of old. I don't want to say old technology, but there's not very many companies that are creating going to electricity. When you go to electricity, you still have to scrub the gas. In most applications, you have to scrub the gas to get rid of the hydrogen sulfide so that it doesn't eat your motor. And so by just creating natural gas and going directly onto a pipeline, you're avoiding that step and that expense of taking it to electricity. And in most cases, net metering or whatever offtake you've got is less financially viable than just taking it straight into the natural gas pipeline.
Okay, so then I have a question. Do you have to scrub it more to make it a renewable natural gas than you would for electricity, or is that the same?
You probably do have to do, the specifications on adding it to a natural gas pipeline are probably more stringent than it would be to run it in your own gen set in your own generator to create power. So yeah, there is some additional scrubbing. We do most of our scrubbing through membrane technology, and so yeah, it's not it is a physical process, but it's not where it once was with iron sponges and a lot of mechanical type scrubbing. It's really just a membrane technology that passes it through. We may have to make some additional passes through those membranes to meet the specifications.
Okay, and then I'm going to ask one more question on the financial part. What kind of payback period does Smithfield estimate it'll take? Do they have?
It really depends on what model you're looking at. If you're looking at the North Carolina model with those small farmers investing, you're looking at a 3 to 5 year payback for the initial investment.
Okay, we have a couple more questions here. So do you know how does the anaerobic process change the microbial community in the finished manure?
Yeah, I don't know the answer to that. I just don't know.
And Lita, Joe Harrison has done some work on that. It changes it a little bit, and if I remember correctly, it makes it a little bit more available, or changes the form slightly, but it's pretty similar. But Joe Harrison has done some research on that, if you want to check. Or it wasn't, Lita, that wasn't your question, but so you can check with Joe Harrison if you want. And then Lita asked, are the covered lagoon anaerobic digesters, they're both covered in Utah and in North Carolina, is that correct?
Yeah, so all of them are, so in North Carolina, they're covered, as well as in Utah, they're both covered. That's the way we collect the gas. In Utah, we have an additional lagoon, which you may have seen in the video or in the pictures, but we have an additional lagoon for evaporation. So in Utah, we don't land apply the manure after it's gone through the digesters. We just evaporate off the liquid portion. We do have some sludge storage capacity designed in the digesters, which after 10 years or so, we'll have to remove those covers and remove the sludge out from underneath that. But we don't anticipate that will be a real problem.
Okay, excellent. Are there any more questions? Jim, I'd like to thank you so much for joining us, and please continue on, but With that, I think we'll go move to the next presentation. This one's actually one from Utah State University, where it's a group of scientists. We're looking at how we can improve our organic grazing systems, but we're specifically looking at the nutrient cycling, adding in legumes, and how that increased nitrogen content may or may not impact the reproductive development of the heifers. And so with that, I'll start that one.
Hi, my name's Clay Isom. I'm an associate professor in the Department of Animal, Dairy, and Veterinary Sciences at Utah State University, and I'm really happy to be able to talk to you a little bit about the grazing research that we've initiated. This project started out looking at beef steers and grazing a variety of different forage types, forage combinations, grass only, fertilized grasses, grasses in combination with different types of legumes. The research started looking at tall fescue in combination with bird's foot trefoil, which is a non-bloating legume, or alfalfa, which is more typical of what we see here in the Intermountain West. The results of that project told us that the greatest average daily gains in beef steers came when tall fescue was planted in combination with bird's foot trefoil, which went a little bit contrary to our original starting hypothesis, which was that alfalfa, grazing alfalfa with a bloat protector block would result in the best gains. We realized that there wasn't a lot of research being done on forage being fed to organic or grass-fed dairy animals here in the Intermountain West. And we thought that it made a nice logical progression to look at these different forage combinations in developing dairy heifers, specifically at this point, in follow-up to our previous study with the beef steers. One of the additional findings that came out of the previous study with the beef steers and the different forage combinations was that the combinations of tall fescue and bird's foot trefoil or alfalfa didn't yield the type of intakes and gains that might have been expected otherwise or predicted by various formulas that are out there in the scientific literature. And so we devised an experiment that was a combination of 4 different grasses, which included tall fescue, meadow brome grass, perennial ryegrass, and orchard grass, a high sugar variety of orchard grass, planted either alone or in combination with bird's foot trefoil. And we planted these in a series of plots at our research facility in Lewiston, Utah. And on these grazing plots, we turned out a number of young prepubertal or peripubertal Jersey heifers. And the aim of this experiment was to see how these developing Jersey heifers would respond to the grazing experience, and specifically how they would respond to the different forage combinations, either the different grasses alone in monoculture or in combination with the bird's foot trefoil. There's some suggestion in the literature that in highly fertilized pasture, the blood urea nitrogen content in growing heifers or even lactating or growing dairy or beef cattle can reach highly detrimental levels, specifically to reproductive performance. A lot of interesting data coming out of this. We've got a multidisciplinary team, very broad and talented team from lots of different departments here at Utah State University. We're involved with extension personnel all across the Intermountain West. And each investigator or each part of this team is finding very interesting and valuable information in their own right. We're looking at a variety of other endpoints, growth, nutritional physiology, rumen health and well-being of these animals, behavioral standpoints or endpoints such as rumination and reproductive behavior, as I mentioned. We're looking at a variety of different environmental endpoints that would help us to understand how nitrogen and other nutrients, phosphorus for example, are cycling through the environment in these different pastures, either in monoculture pastures or these mixed pastures, and how that might relate to concepts of environmental sustainability. We're also undertaking an economic analysis of these endpoints that take into account such factors as the yield, the production characteristics, the dry matter intake, the growth of the heifers, their performance.
Hello, I'm Rhonda Miller, and we're at the Utah State University Intermountain Irrigated Pasture Facility at Lewiston, Utah. Today we're going to look at a study that's examining nutrient cycling in an organic grazing system. Specifically, we're looking at different forages, grasses, with and without bird's foot trefoil, a legume that contains tannins. And we're looking at how those nutrients impact the rate of gain, the nutrient cycling, and especially how much is being lost in the leachate, and also how those nutrients impact the reproductive growth of our developing heifers. If you'll come with me, we'll go take a look. We're here on my plots. Ours are on some skinny strips so that we can cover or match some zero tension lysimeters that were previously installed in this field. We're looking at the nutrient cycling or environmental impact component of this study. And so you might be wondering why we're looking at nutrients in a grazing system. You might think a grazing system is perfectly benign. In many ways it is. I mean, you're pulling the nutrients from the grass, and all those nutrients for the most part are being recycled back onto that pasture. But when you actually stop to look at it, those nutrients are not being recycled uniformly. Within any given year, only about 10% of the pasture receives a urine or fecal spot. 90% of that pasture isn't receiving any nutrients back on that system. Those nutrients also tend to be highly concentrated around the water trough. And when we actually look at a urine spot, those nutrients in that urine spot are the equivalent of about 1,000 pounds of nitrogen per acre. Now, only in that urine spot, the rest doesn't have that. But 1,000 pounds of nitrogen per acre is way too much for any of our plants to utilize. The urine is also primarily made of urea, which rapidly converts to ammonia and then is volatilized, which creates its own environmental issues with acid rain, and especially in the case of northern Utah, some PM 2.5 issues. The nutrients that don't volatilize and that the plants don't utilize or intercept, those move down and get into our groundwater system. We don't want nitrates in our groundwater. If we get too many nitrates in our water, it can actually result in blue baby syndrome, and in certain cases that can actually result in fatalities. It's also associated with some spontaneous abortions in livestock. So we're trying to find forages that utilize those nutrients just as efficiently as possible and minimize any nutrient loss, especially through leaching. Okay, and here we are at our trailer. This is pretty well the heart of our lysimeters system. The zero tension lysimeters are 15-inch diameter by 44-inch deep cores, soil cores, that we pulled out, and then we put on a reducer and cap system with PEX tubing underneath. Those cores went back into the ground where they were. We have PEX tubing running from various locations in the field all the way up to this trailer, and you'll see we have these little access ports up on the wall. We then put a vacuum onto those ports and pull out the leachate that was collected in the reservoir, and we collect them in these big bottles here, and then we take that back and analyze it for the nitrates and phosphorus that are being leached in the system. So the beauty of the zero tension lysimeters, were installed in the field many years ago. We can actually plant and till over them, so we don't have to disturb them. And they collect all of the leachate through the whole year. So even in the winter when we can't get out here, the leachate is moving down past that soil root zone into the reservoir. And then as soon as we can get out here in the spring, we collect that leachate. But that way we collect all of the leachate through the whole year. What we do see is we see huge flushes of nutrients being moved through that soil profile with the snow melt. And we do get a fair amount of snow here, so that's always a big issue each year. So that's one of the things we really want to look at. Here we are at one of my suction cup lysimeters. We have these in every paddock in this pasture. The suction cup lysimeters are a PVC tube with a little ceramic cap down at the bottom. Those tubes are about 3 foot deep. And we actually have them covered with a metal plate. Inside, an irrigation cover. And then in there is a rubber tube access port. We pull that little ring off, put a little tiny tube down the suction cup lysimeter, put a vacuum on it, suck out the leachate. We then put a new vacuum back onto that tube, close it off and seal it back up for the next week. And that's how we collect our leachate. So these we collect every week during this grazing season, and we go as early in the spring as we can to as late as we can in the fall. But during the winter, we are not able to collect leachate on the suction cup lysimeters. So here we are at our root cages. We're actually looking at how the plants grow and how the roots, how much of a rooting system there is, how deep that goes, because we think that may help explain why some forages are better at utilizing the nutrients than others. So in these cages, and these cages are just to protect our tubes from the heifers, we have acrylic tubes, and they have a little cap, and there's a little black styrofoam tube that goes in that, and that's to help prevent any light from intercepting, because the light down there would change how those roots grow. We then take a circular scanner, drop that down the tube, and take segments, a scan of the roots at 1 foot increments. We go down for 4 feet, and then we take those back to the lab and we stitch those images together, but we trace them. We can measure the root diameter, the root length, and we hope that that will help explain what's going on, or some part of what's going on as to why some forages are better at utilizing nutrients than others.
A couple of different specific research endpoints that we're looking at that we're really excited about is one is to evaluate the rumen health of these animals. We know that the inputs that go into the rumen can have a dramatic influence on the rumen microbe population and the overall rumen performance and rumen health, which is an essential characteristic for growth and performance of these animals. So every 35 days we've been going into these Jersey heifers and pulling rumen fluid from these animals and trying to monitor changes over time as these animals come from a feedlot setting and then get put onto grass, but also looking at characteristics of just overall rumen health, such as rumen pH and rumen contents. We will ultrasound them to identify their reproductive status, whether they have initiated their reproductive cycles or not. We'll monitor their internal reproductive organs, as well as some of the external indicators of puberty and development, such as the mammary gland, and tie that together, those together with hormone data that we can gather from the blood that we pull from these animals, and as well as reproductive behavior data that we can pull from the pedometers and some of the biometric endpoints that we're getting from. And in fact, at the end of each of the research years, as we bred those animals, we saw very little suggestion, in fact, no suggestion, that the higher protein content of our mixed pastures were doing anything to compromise the reproductive performance of these animals. This has been, as I mentioned, a 3-year project so far that we have been involved in. We also have a variety of local and regional producers that are involved, stakeholders that provide a wealth of information and suggestions to us as we meet with them on a regular basis to discuss this project, one of the suggestions or one of the questions that almost always comes up is, well, how will my Holsteins, for example, or any other breeds of cattle, how will they respond in the same way as these Jerseys? We know that there are breed characteristics that set these breeds apart from each other, both in their growth, performance, their response to forage, and different dietary considerations. And so that's something probably that we'll undertake starting this next year, and perhaps moving forward, if we could attract some funding for this project, would be to look at some of the same endpoints, reproductive performance, nutrient cycling, growth performance of the animals, yields of the pasture, dry matter intake, a variety of different parameters that would help us to understand whether different breeds of cattle perform differently in a grazing setting as far as dairy heifer development goes.
Okay, so that concludes that video. If anyone has any questions, I'd be happy to take those. You can type them in the chat box. And I'm not seeing any questions. So with that, I think we will move on to the next presentation. The next one is alternative management strategies for land receiving manure and lagoon water in Idaho. And the purpose is to highlight the potential ways that the cropping system management can help overcome nutrient management challenges faced by dairymen.
Hi, I'm Dr. Linda Schott. I am the Soil and Nutrient Management Extension Specialist for the University of Idaho, based in Twin Falls. Idaho ranks 4th in the nation for dairy production, and most of that dairy production occurs here in southern Idaho. The purpose of this video is to highlight ways that cropping systems management can help overcome nutrient management challenges that dairymen face here in southern Idaho. In addition to milk, dairy cows produce urine and feces. These byproducts are collected, and they'll typically go through some sort of separation technology to help separate the liquid from the solid. Next, these byproducts, which are either manure, compost, or lagoon water, can be land applied. These byproducts are not waste products. Even though we often refer to them as waste products, they have a lot of value, specifically as fertilizer. They contain a lot of soil and plant essential nutrients, such as nitrogen, carbon, potassium, and phosphorus, as well as other micronutrients. However, these dairy byproducts don't necessarily contain these plant essential nutrients in the right ratio to grow crops. For instance, when you apply enough compost or dairy manure to supply enough nitrogen to grow a crop like corn silage, you're over applying phosphorus and potassium. While not inherently dangerous, eventually this will or can lead to water quality impacts. However, if you apply these nutrients at a phosphorus or potassium rate, your crop will need more nitrogen to reach its full potential and have the highest yield. Next, we're going to hear from Marcia Niebling from Niebling Consulting about some challenges that dairymen face here in southern Idaho in regards to managing their dairy byproduct nutrients.
I'm Marcia Niebling, and we've lived here in the valley for 28 years. I started this business in 1998 as the nutrient management planning and the whole system was developing. And so since then, I started out working in Idaho with dairies, and since then I've expanded to work also in Washington and Oregon, and it's been a very interesting work. The biggest challenge that I see is that they have to figure out a way to distribute their manure so that it helps with crop growth, but doesn't hurt surface water, groundwater, and the air. And that's a big challenge, especially for nitrogen and phosphorus and salts. Just to keep those all where you want them is a challenge. Part of it is what they need as far as feed, and part of it is what they're comfortable with as far as some people want to be out on the edge trying new things, and some people want to stick with tried and true. And so a lot of it goes back to those two things, which side they want to kind of operate on as far as trying new things or not. A lot of people grow triticale. Most dairymen at some point or other grow triticale, but with their corn. But people are doing more other things now. I've had people lately saying, well, the chopping is an issue for the triticale, so I'm growing barley. And it's a little easier to manage. Or, some people are doing sorghum Sudan grass and things like that. So.
We also went to talk with Ed Obadike with Obadike Dairy about how he is putting these innovative strategies into practice. He's moved away from a traditional alfalfa corn silage rotation into a more diverse one to help address his nutrient management challenges.
I'm at Obadike in Mountain Home, Idaho. We have a dairy out here and milk about 2,500 cows. We have our replacements on hand, and we're visiting today about our nutrient management and our crop rotation. We do export most of our manure, like 90-some% of it, and it's kind of something that I enjoy doing because the farmers want to take it, if they want it, I don't want it here, because I keep my numbers down, and someday if I have to put it here, I have that ability. Basically around here, we have very low organic matter in the soil, so it doesn't hold water that well, and it's very, very low, like in the 1% range. And so they like to get the manure, because basically, yeah, there's no minerals in there either. Phosphorus, it doesn't hurt them at all. They need the phosphorus. They need the nitrogen. It takes years in the soil to become fertilizer, but the guys that are taking it are patient, and they realize that they got this white dirt that's low in organic matter and it has no bottom under the pivot tires, and they all say that by routinely applying manure, it kind of helps some of those problems. So every single year we've kind of been reevaluating because of the forage needs and the water issues. I think we get kind of back to where we need to be. You will probably stick to rotating 2 pivots of triticale and Sudan grass, and then 1 pivot. We'd probably like to keep 1 in Italian ryegrass and 1 in corn. So some kind of rotation. We don't want to keep the same thing going all the time. But we don't really have a set rotation at this point. So, and as far as phosphorus and nitrogen uptake, corn does not do a real good job. The numbers that are in the book do not apply at all to what it actually does. And Sudan grass, it's also a warm season grass, but it comes in that time when the ground's warm and it's ready, and it pulls nitrogen really well. And triticale, all cold season grasses really pull nitrogen and phosphorus out of the ground. And when you can throw the Italian ryegrass into the mix, it really uses up a lot of nitrogen. What we would do with it is you would plant it in the spring and take 5 cuttings off of it. And then it'll like vernalize over the winter because it will not mature and throw a seed the first year. But after frost, then the next spring, you cut it and you get a really nice big crop, but about a month before alfalfa. But you got to get it before it matures. And then once you get it off, then you'll strip till corn into that, and that works really well. So, you know, the grass is there to kind of suppress the weeds, keeps the ground loose, you know, and then also, you know, the cool season grass, it really fixates the phosphorus for that corn. So that's a nice rotation too. But with the limited water, Italian ryegrass really likes water. With the limited water, we haven't grown any, but I anticipate growing some more, you know, next year. So it's a 1 year crop, year and a fifth crop. And it will make 10 tons of dry matter in a season. So it does compete with corn for forage yield. I don't want to be married to something for 5 years in case we you know, need to get rid of some you know, solid stack or waste that we weren't planning on. You know, I like to be able to grow other forages that wet forages that we can't buy elsewhere.
In addition to having a more diverse crop rotation, Obadiah Dairy has also adopted new irrigation technologies to help not only reduce their pumping costs, but also allow them to apply lagoon water in a more efficient manner. In this field, and actually all of his other fields, Ed has converted his irrigation system into a drag drip system. And for this, the nozzles or tubing are dragged on the ground so that irrigation water loss is very minimal. However, the openers on these are so small that it's difficult to put lagoon water through the system. So he's also incorporated these overhead sprinklers so that especially in the winter, he's able to apply lagoon water to his growing crop.
As it converted, as we'd heard about it, then, you know, we did not have the nozzles. It was just, they converted it directly to drip. And we grew corn out here, and, you know, all the agronomists and everybody's like, you can't grow corn on, you know, 550, 600 gallons per minute on pivot. It'll never work, never work. And they kept coming out, and, you know, they were kind of shocked all year, and it ended up being, you know, a great crop. So we will grow 2 triticale crops over the winter. So we spread our lagoon water in the fall and in the spring on those crops, and that's how we get our lagoon empty. And it takes up, we double crop those fields with Sudan grass generally, so it takes up the nitrogen and phosphorus that we get put out on that.
Dairy manure and compost are high-value fertilizers with a lot of worth. They are not waste products. By properly managing them, they can really help improve soil health metrics by including more carbon in the system, improve infiltration, provide plant available nutrients, reduce runoff, again, when properly managed. By critically thinking about their nutrient management and cropping rotations, dairymen like Ed Obadiah are able to maximize their forage production while also maximizing their ability to apply lagoon water, dairy compost, and dairy manure in a way that prevents accumulation of soil nutrients like soil phosphorus and soil potassium that may have a negative impact on water quality and crop production.
Okay, that's this video. If you have any questions, please type them into the chat box. Linda is here with us, and so she's here to answer any questions. And Linda, you're still muted. I'm going to ask you to unmute. So are you starting to see quite a few of the producers trying different cropping systems, or is Ed really the lone leader?
I mean, there's a few producers that are trying new things. There's several producers that have incorporated cover crops, but really it's only if they're able to graze with beef cattle alongside their dairy operation. So that's a pretty specific practice. There's a few producers that have tried the spirit grass, ryegrass to get the multiple cuttings and just pull more out of the soil, especially in the winter. But there's still not that many. I mean, most dairymen are still doing a typical corn silage alfalfa rotation and maybe throwing in triticale as a double crop if their numbers are getting too high, just to pull more. I think Ed is one on the leading edge, and I think it's really because of water issues, not so much nutrient issues, but still the same purpose, I guess.
Yeah, and so I take it water's really quite limiting up there.
Where he is, yes. He's on a groundwater district where water isn't as limited. I don't think dairymen are necessarily taking it to that, I guess, level of innovation, but they're still innovative. Don't get me wrong. They're just not so concerned with their pumping costs.
So how long has he had the drag drip lines?
He said about 2 years. He converted the first one 3 or 4 years ago, and it's been a couple. He's had some lessons learned with that, and has just gone all in and has decided that even replacing all those drag lines every year or two is totally worth it in terms of what he's saving pumping wise, and also just applying more water directly to the soil rather than having evaporation loss. He just is thrilled with it. So
that's interesting, because I would think you would just want to lower the nozzles down really close to the soil surface rather than trying to drag.
Right. Yeah. So Lisa systems, I think, have more adoption than the drag drip here, because there's just they don't have the blowout issues with basalt, where they're not necessarily ripping those drag lines up as they drag on the ground. But I didn't know that he had converted to a drag drip system until I got there. I was just there to talk about all of the crazy things that he was trying to grow, which aren't really that crazy, but for Idaho they are. And he was showing me this irrigation system, and I was pretty excited about it. So.
And we have a question. When he says that most of the manure goes to other farmers, he's referring to the separated solids, right?
Yeah. I mean, all of his, it's an open lot dairy. So, and I didn't mention that, but so most of it is scraped, and then that goes, that's windrowed and taken to other farms. I guess farmers will come in and get it. And he says when he can, they'll vacuum if it's wet enough. But most of it is just solids. It's just dry scrape, dry lot.
Okay, great. Thank you very much. And with that, I'm seeing no more questions. I think we'll move to the next presentation. That is the use of centrifuges for dairy manure solid liquid separation.
Hello, I'm Li Dechen, a waste management engineer with the University of Idaho. Idaho has a strong dairy industry, ranks among the top 5 milk production states in the nation. As a byproduct of milk production, huge amounts of liquid manure are generated each year in Idaho. Solids and nutrients in the liquid manure pose several challenges to manure handling processes. Most of our dairies are familiar with the benefit of solid liquid separation. A few have incorporated the secondary solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation. The secondary solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The objective of this video is to demonstrate the benefits of solid liquid separation technology on their dairies. The is to showcase the use of centrifuge as a secondary solid liquid separation technology on 2 Idaho dairies. Prior to visiting dairy site, let's hear Rick Nearbout's perspective on solid liquid separation. Rick is the Chief Executive Officer for the Idaho Dairymen's Association.
All right. So Rick Nearbout, CEO with Idaho Dairymen's Association, and today we're talking about manure separation and why we encourage dairymen when they can to increase the separation efficiency on their dairy operations. And there's a number of reasons to do this, and there's some very unique technologies like centrifuges that are out there starting to be employed by dairy producers here in the state of Idaho. You get a number of benefits from increasing separation out of your liquid manure and that liquid manure storage area. First, you have to clean out that liquid storage area less often. If you have too many solids in your lagoon water, it's going to settle out and you lose storage capacity, as well as have a lot of sludge and slurry at the bottom of your ponds, and that requires cleaning periodically. So if you can limit the number of times you have to clean your lagoon, there's a direct financial savings there, and you don't also possibly disturb the integrity of that lagoon liner. So from a management standpoint, that's one of the early benefits. Some of the other benefits that aren't as widely recognized, one would be as you take solids out of liquid manure, you also reduce the emissions coming off of that lagoon. So if you're looking to reduce your environmental impact on air quality issues, pulling those solids out are gonna reduce that emission factor coming off of that lagoon storage area. So there's a benefit to air quality that can be recognized. And then the last area would be the ability to move nutrients further away from the dairy operation itself. If you're pulling the solids out, you can put them in a more transportable form. Typically the phosphorus and nitrogen are largely gonna stay with those solid particles. And so as you pull solids out, you also pull those nutrients out, and you can move them further away from the dairy operation and not end up with concentrations of high phosphorus or nitrogen in the fields that are surrounding the dairies. So a number of reasons to look at improving solid separation and a number of ways to do it. We just really encourage dairymen to incrementally increase their solid separation. If they're, they don't have the capital to go all the way with a very advanced system, do what you can to just incrementally improve that separation on your facility, and it'll have benefits for the future for you.
Hi, my name is Dean Swagger, and I own the farm here. And we have been here in Idaho since the year 2000. Prior to that, we dairied down in Southern California in the Chino Corona area. This farm was started by my father in 1945, a small number of cows, and it's grown into what we see today. Today we milk about 4,800 cows, and we have 2 facilities, approximately 1,000 acres in total, which we farm also, grow some of the feed for the cows. And in a nutshell, when a lane is flushed, it goes down to the first receiving pit. The first receiving pit pumps over some core screens, which gets the initial solids out. It then flows from those screens down to a bottom removal pit, which we call it, which is shaped like a V at the bottom with a pipe, and that pump turns on again based on fill to pump off the bottom solids that have settled to the bottom, off to another pit that in turn feeds the centrifuge. The centrifuge runs at about 250 gallons a minute, which polishes the water, takes out the solids that the core screens have missed. And also the reason we have core screens is to take out the initial solids and any debris that might damage the centrifuge. After the centrifuge, it's back in the system once again to be reused for flushing. I don't know exactly, but I would say probably in the 7,000 to 10,000 gallons, based on how many minutes the flush pump runs for each particular lane. There's I believe it's like a 12-inch pipe from that flush pump up to the top of the dairy that feeds the valves that are up top. Give or take 7 to 10, I would say. Minutes of run time. You know, the lanes that the cows eat in versus the back lane in the back of the beds, there's a 2-minute differential there, because most of your waste is going to be where they eat. Clean water comes this way and the dirty solids go that way. Yeah, yeah. It comes in through that pipe there, and that particular pipe runs all the way down here with different places that it injects. This is the control panel for the centrifuge. Right. I can tell you when it's running. We run at about 1,600 RPM. There is, I think it's a 125 horsepower motor to turn the barrel on the outside. And there is, I think, a 50 horsepower motor that turns the auger on the inside of that barrel. Each one of those is within a paper tolerance of each other as they're turning. Now the auger on the inside is regenerative because it's always trying to hold back. If the main barrel is running at 1,600 RPM, the auger, and it's all controlled by the PLC, the auger might run at 1,590 RPM. So it's always holding back. So actually that horsepower is regenerative. So if the main drive is pulling like 85 amps, the back drive is pulling like 35 amps, and it's actually taking away the amps that are on the larger motor. So it doesn't take as much power as one might think. Now, the operation of the centrifuge, the auger on the inside, when solids are spun, they're spun and they stick to the outside, just like your wash machine does with your clothes. That auger, turning a little bit slower, pulls them solids at a constant rate and brings them up an incline inside the centrifuge, and it gets drier as it goes. So when it finally ends up dropping out of the centrifuge through nozzles on the end, it's dry enough to make a coned pile off the end of the centrifuge. Eight from the primary screens and 4 probably from the centrifuge every day. I would say prior to the centrifuge, we were probably only getting between 5 and 6 loads total per day. And once we put the centrifuge in, the primary screens worked so much better, and also we were removing all the fine fines that were always so hard to get. Once a week we pressure wash our screens and acid treat them whenever necessary. The centrifuge goes down once a week and we grease it because there's bearings on the inside of it, and there's a proper method of maintaining the centrifuge. Basically, the centrifuge doesn't require a lot of maintenance other than once a week. Grease, mainly. I don't need to clean my lagoons hardly ever. They have been, you know, before it was a full-time job to stay ahead of lagoons. Every year I was cleaning at least one lagoon, and now that's not necessary with the centrifuge. With the centrifuge, you can see the tire tracks at the bottom of the lagoon that you cleaned from the year before, the next year. Absolutely. I think every dairy farm could utilize the centrifuge in some way or another.
We're at Betancourt Dairy number 1 of our 9 facilities that we have. Currently we're milking just under 13,000 cows and irrigating about 1,000 cows off of, or 1,000 acres off of our lagoon. We started this facility in 1999, so it's 20 years old right now. We remodeled about 3.5 years ago from an open lot to a cross-fed facility, and at that time is when we updated our manure system. At Dairy One, the process flows from the cross vent being vacuumed, from the vacuum dumped into a pit where it is mixed with barn water. From that point, it gets sent over a sand lane to try to desand as much as we can. From there, it is dumped into another reception pit. From that pit, it is pumped over 2 sets of slope screens. The 2 slope screens then pump it out into the next pit, and from that pit 2 more pumps pump it back over 2 centrifuges. Both centrifuges and slope screens are parallel with each other. From that point, it leaves the centrifuge and dumps into another pit, and from that point it is pumped up to the lagoon. We are processing approximately 700,000 gallons of water manure a day through the slope screens and centrifuges. The sand lane is cleaned twice a day. In all reality, it could probably be cleaned 6-7 times a day. It's just it's labor intensive, and you have to hit it when the sand or the flush lane isn't running, so it's a timing issue. Yes, no water is brought back onto the dairy. It all goes to the lagoon and then through a pivot system pumped onto our fields. Approximately 22 ton a day from the slope screens of fiber. 20 to 25% of that, 100% of it is composted, and then 25% of that is used for bedding, and then the remainder is shipped off-site, sold or used on some of our other fields. From the centrifuge, the cake, we are approximately 24 ton a day. The reason there's so much weight there is just the sand dropping out and hauling that off. The screens have an auto washing system that runs approximately 6 times a day. That is really how we keep the screens running at the pace that they're running. If we didn't have the auto wash, I'd have to have a guy come in 6-8 times a day and manually shut it down and clean it. If it were to fail, you got about 12 hours to get it going again, else you'll be out there cleaning it. From there, it's cleaned weekly through the screw presses and everything underneath, just maintenance, cleaning up any residual manure that's fallen over. But once a week, roughly, we tear it down and put it back together. The centrifuge, once a week, We have a company come out and shut down each centrifuge, clean it. There's a flush system that goes through it. From there, they check in the oils. It's got a air pressurized drip system to lubricate the bearings. And then once the plan was, or the budget was, once a year to do a bowl exchange, where we will come out and they'll pull it out and put a brand new rebuilt from the factory in. Right now we went 15 months, so we're doing better than we realized. When we added the second screen, we think we'll do even better. We're not going to be hammering those centrifuges as hard. Basically, the centrifuge, you know, at the RPMs it's spinning and at the volume of water getting pushed into it, it's sanding it down. The first maintenance, we found that the inside of the centrifuge was relatively in good shape, a lot better than what we had planned. But the very end of the centrifuge where the water is hitting, it looked like somebody just sandblasted the wall in, dented it in, just wore it out. You know, if we could control that, that would add more time onto the life of that centrifuge. So the second centrifuge was added after our goal was to capture all of the water. And with one centrifuge, we were able to screen all the water, but we were not able to run the water through the centrifuge completely. By adding the second one, we were able to slow down the amount of water coming in, speed up the centrifuge, and our capture rate increased, not only from the extra 150,000 gallons that we're capturing, but by slowing it down, we were able to keep that water in the centrifuge longer, spinning more of the particles out. We're guessing that increased it by about 2 million pounds more a year, just by slowing it down, not by adding the extra centrifuge, just by slowing it down and capturing more particles that were going out to the lagoon. Yeah, the hopes were we can go from, you know, conventional open lot once a year cleaning the lagoons with the slope screens and then the centrifuge added on. You know, that's what, 440,000 pounds of manure that you're, you know, trying to not have to pull out of that lagoon. Fuel, labor, a lot of other issues come onto there. So going to every 3 years will easily pay for the second centrifuge. The main goal, obviously, is our field. You know, to get rid of the manure. You know, we want our fields to produce better. If we don't process it, our fields will suffer. That's number one. Cleaning, money savings, labor, it all ties together. The other goal is just, you know, the standards are going to get tougher. We already have, you know, ammonia management systems and everything, and in time I see it getting tighter and tighter. And you know, we want to be good stewards, so we want to do the right thing. I feel this is the definitely beyond the first step of that direction, but it's a big step for us, and I feel we're doing the right thing and going the right direction. The two centrifuges I've said this before, we weren't promised anything that we didn't get. We were told it's going to be X amount of dollars a month to run, and about once a year, plan on a little over 100,000 to repair. We're at 15 months, and we're actually only like at 80,000. So they told us it would take about 50% of what you're going to put into it come out of it. Obviously, if you get too thick, it really skews it, and there's a certain point when you're running almost water, you're not going to get that. But on the average, 3%, anywhere we put into that from 1.8 to 3.8% solids going into it, and that equates about half every time. If I were to do it again, where this is not a flush dairy and it's a vac dairy, I would not mix the water with the manure coming off the vac truck. Basically, you're taking good 13% manure and diluting it down so that you can run it over a screen, so that you can thicken it back up and pile it so that you can centrifuge it. I think I would have went straight from the vac to a screw press system and then to the centrifuge. Would have used less of the clean water. We'd only process, I believe, it was going to be 250,000 gallons a day through the screw press and centrifuge. The rest, we could choose to run it through the centrifuge, but the water's pretty clean. We just maybe run it over a slope screen and send it to the lagoon. Number one for me would be, we've got the solids figured out. We know that just processing to whatever extent you're going to get there, whether you're using polymers in the centrifuge or just conventional, you got that. It's the dissolved solids. You know, if we could find a way to get those dissolved solids captured through, you know, a feasible technology that's, you know, affordable, that would be, to me, the biggest reward for all this, or game changer, if you want to use that word.
We hope you learned something from this video that advances your knowledge and helps you make better decisions about upgrading your solid and liquid separation technologies. Please contact us if you have any question, comments, suggestion. Thank you for watching.
And thank you. If there's any questions, if you'd please type those into the chat box. Lita is online with us, and so he can help answer any questions. Hi, Lita. So I've got one question for you. The first producer said that after he added the centrifuge, that it actually made his screen produce more, separate out better.
Correct.
Do you know why that would be? Or
you know, my thinking, since that there they reuse their water, so whenever we use water, so basically the screen cannot get a finer particle out of the liquid. So that way, I think maybe plug their screen pretty more often. But with the centrifuge, they can get a more fine particle out. That's kind of help the screen work better. He didn't mention what's written, but he did mention before a centrifuge, he can get, I think it's 5 to 6 nodes per day, but after centrifuge, they can get roughly 7 to 8 nodes per day from the screen, and another extra 4 nodes from the centrifuge.
Yeah, so they're pulling a lot more out then. And then, so yeah, so they were, that first producer, they were recycling their flush water before too.
Yeah, think about it, every day, roughly 500,000 water they need to flushing, I think he's 16 manure lands. So there's no way without reusing the water. I think probably their water right is the same thing in Utah, right? They don't have so much share for the water. That's my guess.
Okay, and then one other question for you. The second producer, he said that they were composting some of the solids, but they also obviously use sand. So they use both types of bedding?
No, in the Magic Valley, nobody uses sand as bedding. All the sand is kind of blow in. See, you know, in our area, I think people always see 2 times wind each year, but each last 6 months. Almost every day, they're windy.
Okay, so it's sand being blown in then, huh?
Just blowing in.
Okay, interesting. Okay, I'm not seeing any other questions, so we will move on to our last presentation for the day. Thank you, Lita, very much.
Thank you. Yeah.
We'll move on to our last presentation, and that is with Mario, and it's ammonia and odor reduction while retaining nutrients, a dairy producer experience in Idaho. So this one will cover slurry dairy manure application using a drag hose and subsurface injection, and also a pilot zeolite filter trial to reduce odors.
Hi, I'm Dr. Mario de Aro Marti, Extension Educator with the University of Idaho in Gooding County. This video will discuss two techniques available for dairy producers to reduce ammonia and odors emissions and better manage the distribution of nutrients. First, we will showcase a manure drag hose and subsurface injection system used by a dairy producer in southern Idaho. Then we will highlight an experimental zeolite filter that the same producer helped to test in his facilities. Drag hose and subsurface injection consist of 4 distinctive parts. First, a way of mixing the liquid manure storage pond to get as much as possible of the settled solids to mix and create a slurry that can be pumped. Second, a pump that can handle the slurry and pump it at considerable distance. In this case, the producer uses a floating pump that serves both functions, mixing the lagoon, then switching to pumping the slurry manure into the drag hose. The third element is the drag hose itself. The hose transports the slurry from the pond up to the injection tool. Those hoses are designed to support high pressure and to be dragged through the fields. The final component is the injection tool. This implement distributes the manure received through the hose into injecting tubes and tools that can go several inches below the soil surface and inject the liquid manure where the crop roots will be. You can see how no manure is visible on the surface. Using a drag hose and subsurface injection system allows livestock producers to better manage their lagoons, applying manure slurries and their nutrients closer to where the crops need them. It also reduces ammonia and other emissions. A video and a publication explaining the technology, economics, and environmental benefits in southern Idaho are available on the UOI Extension Nutrient Management website. Okay. Let's hear from Dean Swagger, the dairy farmer using the drag hose and injection system in his dairy farm.
Hi, my name is Dean Swagger, and I own the farm here. And we have been here in Idaho since the year 2000. Prior to that, we dairied down in Southern California in the Chino Corona area. This farm was started by my father in 1945. A small number of cows, and it's grown into what we see today. Today we milk about 4,800 cows, and we have 2 facilities, approximately 1,000 acres in total, which we farm also, grow some of the feed for the cows. And in a nutshell,
the drag hose, the reason I purchased that is because it's a tried and true technology that's been used for many years. More in the eastern states than here, but if it works there, why wouldn't it work here? I needed a better way to not go into the lagoons and disturb the bottom of the lagoon with heavy equipment, and also a way of removing that slurry without using a year's worth of drying, you know, even in ideal conditions, to get that slurry dried up enough to where it can be hauled out. This, I can use the system we already have. You just put the boat in there and start pumping. There's no prep involved. in this, and nobody is covered in cow manure at the end of the day. It works, and it also puts the drag hose system with the injector, puts the nutrients where you need the nutrients, not on the surface. It puts it down below where it's plant available. I think we're running right at about, on a good day, we're running about 1,000 gallons a minute through the injector. So we can put a lot of product on in a short amount of time. It works very, very, very well. Diesel. You know, it's only something that's being used, you know, to maybe a month out of the year. The cost of the, you know, there is maintenance, of course. You got your diesel, oil changes, filters. I think the most consumable item is your drag hose itself, the last 400 feet or whatnot of it that physically drags across the ground, because you're pulling it with a tractor and an implement. That hose is probably $3 a foot, and it probably lasts about 3 years. The year prior to buying the drag hose system, I used Tankers, a custom company, to come in and pump out a lagoon or two. I forget what it was, but with the cost of that versus the cost of the drag hose system, I can probably pay it off in about 1.5 to 2 years. This is, well, yeah, I could go on for a while on that. Benefits is peace of mind, that you have the capacity. You once again have the capacity in your lagoons after you're done. Your nutrients are where you want them to be and not on the surface, because a lot of times on the surface you just burn that seed and you put it down below, you know, 10 inches down. You put it where the plant needs it when it's mature enough to handle those sort of nutrients. On and on and on. Our yields are so much better now on the farm. The crops grown are so much better. They're not affected by number one, trucks, spreader trucks driving over the top, compaction. Number two is nutrients.